Algebra 1, Section 2.5, a huge list of properties. Unfortunately, I couldn't copy this out of the online textbook because that doesn't exist anymore. So this is taken with my cell phone and emailed to myself and clipped with the snipping tool. If you want to look at this in your own book, it is on pages 86 and 87. If these, this is the best I can do, but if these don't show up so well for you on your computer screen, you have a hard time reading them, you can see them for yourself in the section. Okay, so I'm going to talk through a lot of this. I don't know that I'll touch on every one of these because I want to, as I've told you, try to keep these videos short. But I'll first say that this is not a situation where you gotta know every one of these properties, and if you don't know them, that's the one I'm going to nail you on the exam or whatever, the test or the exam. That's not the case. I would much rather you know how they work than know the names of them. But that being said, as we go through this section, you should get comfortable with the names of them as well. And just to take the first two, you have the commutative property of addition, and then you also have the commutative property of multiplication. You should see why that is, right? Why is it that they have the same name, commutative property, but for different operations? And I love that they give us an example for each. So the commutative property, which is in plain terms, a plus b is equal to b plus a. Here's an example. 3 plus 7 is equal to 7 plus 3. Isn't that true? You add 3 and 7, you get 10. You add 7 and 3, you get 10. Just to basically say that it doesn't matter which order you add things, you're going to get the same sum. And it is the same case with multiplication. A times b equals b times a, because 3 times 7 equals 7 times 3. Or 10 times 40 equals 40 times 10. Whichever two numbers you want to use. You can multiply things in any order. Did you notice that there isn't a commutative property of subtraction? Do you know why? Because 5 minus 3 isn't the same as 3 minus 5. So there isn't a commutative property for subtraction. Now, associative property is kind of just the next logical step in what I just said about the commutative property. If you can add things in any order, then let's throw a third term in there, and it's still the same case. If you are adding 6, 4, and 5, you can add the 6 and the 4 first, or you can add the 4 and the 5 first. Be careful on this one because I've seen examples before. If there were one tricky problem that I've seen come out of this part of the curriculum, it would be something like this. 4 plus 2 plus 9 is equal to, how would they do it? I guess 2 plus 4 plus 9. And people can look at this and carelessly say, oh, that's the associative property, right? Because there's parentheses and there's 3 numbers. Well, that's not what happened. The plus 9 in the end that's apart from the parentheses, that's the same for both. What's different here is that we flipped the order of the 4 and the 2. That's the commutative property of addition, right? So if I asked you what property is being shown here, commutative property of addition. If there's an associative property for addition, you can see that there's an associative property for multiplication. And then we get into the identities. Basically, an identity, you think self, for addition, what can I add something to get that number itself? Okay, well, that number is 0. So the additive identity is the number 0 because, as they give an example, 9 plus 0 is 9. How that manifests itself with multiplication, I have something, I want to get that same something itself, that is, back. How will I multiply to do that? You multiply by 1, I'm sure you know, right? So 1 is the multiplicative identity. 0 is the additive identity. 1 is the multiplicative identity because those are the numbers that give you the number that you started with, no matter what it is. Now, each of those goes with its inverse, right? So the inverse property of addition is one that produces the number that will bring you back to the additive identity. The additive identity is 0. So if I have a number and I want the number that's going to be added to it to give me 0, that number is its inverse. Okay? So for example, as they give 5, its additive inverse is -5 because 5 plus -5 is 0. And again, 0 is the additive identity. Same thing with multiplication, except now we're dealing with reciprocals. The inverse is the reciprocal, and they use an example of 5 and 1/5. Because 5 times 1/5 takes you back to the multiplicative identity, which is 1. 5 times 1/5. 2/3 and 3/2. Talking about reciprocals. Okay. Skip the symmetric property. That's not really important. The distributive property, we've already actually had a section on this, but now they're kind of giving it to you in again, general terms and then an example of each. Just make sure you know that when you have a number out here, you multiply it by every term that's in parentheses. So A times B would be AB, A times positive C would be AC. So this is AB plus AC. There's the same thing for subtraction. I'm sure you know that multiplication by zero produces zero, right? Any number times zero is zero. And when you multiply something by -1, that changes the sign. Okay. Now, with all that in mind, and maybe it would be a good idea to pause the video and kind of just review it again yourself. With all that in mind, though, let's take a few examples. This says name the property each equation illustrates. And again, please understand, I'm not going to fill up your test with a bunch of problems that say name this property, name this property, name this property. That'll be represented. I mean, you can expect to see a problem, maybe two, with that are getting at this concept. But it's only one concept, right, out of a test that's 10 sections long. All right, so what is it? 3 times A is equal to A times 3. That would be the commutative property of multiplication. If I'm going too fast, pause the video if you need more time to think about it, because we're multiplying things in different order. What about the next one? That would be the multiplication property of 0. You're multiplying P by 0 and you get 0. That's the multiplication property of 0. What about when we add 6 to -6 to get 0? That would be the identity property of addition. No, excuse me, not identity, inverse property of addition. 0 is the identity. 6 plus -6 takes you back to the identity. But that is the inverse property. Okay, next example says, suppose you buy a shirt for $14.85, a pair of pants for $21.95, and a pair of shoes for $25.15. I don't know where you get a decent pair of shoes for $25.15, even 12 years ago, but find the total amount you spent. Okay, so here's what they're going to show. Obviously, you're going to add those numbers up. And does it matter which order that you add them? Well, it really doesn't, but don't these two numbers pair well together, right? Because 15 cents and 85 cents adds up to $1. So then you're really adding those together. And if you just added 15 cents to here, you'd have 15 and then 25 left. That would be 40. So that's an application of the commutative property, right? That you can add them in any order. And I'm choosing, really, I mean, you can even argue that it's the associative property. You have these three numbers that you're adding, and you chose to add two together that are compatible, if you will. And then you could add that 40 to 21.95. It's going to be 61.95. Okay. Now, lastly, and again, I kind of make the same point. They say justify each step, and you'll do a couple problems in the homework where you justify each step. This is not where we're going with this long term, you understand? But just the same, how would you simplify this? And what is it that allows you to do that? Well, you would distribute the -4. We've seen that already a couple times. -4 times -8 would be positive 32. So that's the distributive property. Feel free to abbreviate as well. Don't abbreviate too much, so I don't know what your abbreviation stands for, but everybody would understand that that's going to be distributive property. And then these are like terms. 3x minus 4x would be -x. -1x, I guess, is what they're going to want me to do, plus 32. Now, you remember in the previous video where I said they're bending over backwards to make you think that combining like terms is actually the distributive property. So they would put distributive property here. You can call it combine like terms if you want to. Hey, since you're algebra geometry, I think what I'm going to do is show you what the geometry book actually does, and they simply use the word simplify. All you did was simplify. 3x minus 4x, that's simplified. Now, I put the 1 here on purpose because they want to incorporate the multiplication property of -1. So that's -x plus 32, the multiplication property of -1. Okay. Again, I'll show you their work. They have subtraction. Oh yeah, because they did the distributive property here, then they have the subtraction because they subtract the 3 minus 4. And then finally, and boy, that's not correct, is it? That's not the identity. That's the multiplication property of -1. Okay, don't look at their work. Never mind. I'm pretty sure I'm right. All right, thanks for tuning in.